Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Hi everyone, welcome back. In this section we're working through Section 5, Earthing Arrangements and Earthing Conductors. This section explains how earthing systems are arranged in New Zealand electrical installations, how protective earthing and bonding are provided, and how earth fault protection is achieved by automatic disconnection of supply. We'll look at main earthing conductors, mean connections, earth electrodes, continuity, equipotential bonding, and earth fault loop impedance. Everything in this section is critical for electrical safety, because correct earthing limits touch voltages and ensures protective devices operate quickly during a fault. Let's begin with Section 5. Clause 5.1, General. This part explains that Section 5 sets the basic requirements for how earthing arrangements are chosen and installed, so the installation can meet the overall safety goals of Part 1 of the standard. Clause 5.1.1, Application. This clause explains that the rules in this section apply to the selection and installation of earthing arrangements, and these arrangements must be suitable to satisfy the general safety requirements of the standard. Clause 5.1.2, Selection and Installation. This clause explains that earthing arrangements must be chosen and installed so they can carry out several essential functions. These include allowing the supply to disconnect automatically if a short circuit, earth fault, or excessive earth leakage current occurs through protective earthing, allowing equipment that needs an earth reference to operate correctly through functional earthing spoken as FE, reducing dangerous voltage differences between exposed conductive parts and other conductive parts by equipotential bonding, providing a reliable low-impedance path for earth fault and earth leakage currents without damage from thermal, mechanical, or environmental effects, and allowing exposed conductive parts and extraneous conductive parts to be properly connected to the earthing system. Clause 5.1.3, Main Earthing System. This clause explains that the protective earthing arrangements in this standard apply to installations connected to a multiple earthed neutral system, spoken as MEN, which is the standard distribution system used in New Zealand. In this system, the neutral conductor, spoken as the PEN conductor, is earthed at the source of supply and again at regular points along the distribution system, including at each connected installation. Within the electrical installation, the earthing system is kept separate from the neutral conductor and arranged so exposed conductive parts of equipment can be connected to earth. Clause 5.1.4, Other Earthing Systems. This clause explains that earthing systems other than the MEN system may be used, provided the general safety requirements of Part 1 are met and the characteristics of the supply system are taken into account. The examples given include installations complying with IEC 60364, surface mine installations complying with ASNZS 3007, some existing installations permitted under earlier editions of the standard, installations not supplied from a distribution system, and installations using IEC 60364 systems that allow alternatives such as TN, TT, or IT systems. Clause 5.2, Earthing Functions. This clause introduces the different purposes that earthing can serve within an electrical installation. Clause 5.2.1, Protective Earthing. This clause explains that when a fault occurs between a live part and an exposed conductive part, a dangerous touch voltage can appear between parts that can be touched at the same time. Protective earthing is intended to limit this risk by ensuring automatic disconnection of supply. This is achieved by connecting exposed conductive parts to the earth neutral of the distribution system and by using overcurrent or earth leakage protection devices that disconnect the affected part of the installation within the allowed time. Clause 5.2.2 Functional Earthing FE. This clause explains that some equipment requires an earth connection for correct operation rather than for safety. In these situations, functional earthing conductors are not required to withstand fault currents and are not identified in the same way as protective earthing conductors. Examples include functional earth connections used in certain RCDs to allow internal electronic circuits to operate if the incoming neutral becomes disconnected, and conductors used for systems such as cathodic protection or radio interference suppression. Where a clean earth is required for data or signaling, the equipment manufacturer should be consulted. Functional earthing for data and signaling should be insulated from protective earthing and normally connected at only one point, usually at the main earthing terminal or connection bar, and care is needed to prevent accidental contact between the two systems. No specific insulation color is assigned, but green or green and yellow must not be used. Clause 5.2.3 Earthing for combined protective and functional purposes. This clause explains that when earthing is used for both protective and functional purposes, the requirements for protective earthing always take priority. Clause 5.3 Earthing system parts. This clause explains that when an electrical installation uses protective earthing with automatic disconnection of supply and is connected to an MEN distribution system, the earthing system must include all the necessary parts to make it work safely and effectively. These parts include protective earthing conductors to connect exposed conductive parts, a main earthing conductor, a main earthing terminal or connection bar, the MEN connection between the main earthing terminal and the supply neutral bar, an earth electrode, and equipotential bonding for extraneous conductive parts where required. It also explains that all parts of the earthing system must comply with the detailed requirements set out in the following clauses of this section. Clause 5.3.1 General. This clause explains that the protective earthing arrangement of an installation connected to the MEN system is made up of several essential components that work together to allow fault currents to flow safely and to ensure automatic disconnection of supply. These components must all be present where required, and they must meet the requirements of the later clauses that describe materials, sizes, and installation rules. Clause 5.3.2 Earthing conductor material and type. This clause introduces the rules that control what materials earthing conductors may be made from and what forms they may take, so that they are suitable for carrying fault currents reliably. Clause 5.3.2.1 Conductor material. This clause explains that earthing conductors are normally made from copper or aluminium, but other materials may be used if they perform at least as well in terms of electrical resistance and corrosion resistance. Clause 5.3.2.1.1 Copper conductors. This clause explains that copper earthing conductors must be made from high conductivity copper and may be stranded, circular braided, or solid. Where solid copper is used, it must not be smaller than 10 square millimeters in cross-section and must have a minimum thickness of 1.5 millimeters. The clause also explains that smaller solid conductors may be allowed where a particular cable standard permits it, and that copper cable components such as sheaths or screens may act as earthing conductors if they meet the relevant requirements. Clause 5.3.2.1.2 Aluminium conductors. This clause explains that aluminium conductors may be used for earthing, but only if specific conditions are met. Smaller aluminium conductors must be solid, and a minimum size is required for main earthing conductors. Connection methods must follow the rules of Section 3. Installation must prevent corrosion, and aluminium earthing conductors must not normally be installed underground or in damp conditions unless they are specifically designed for that environment. Clause 5.3.2.1.3 Other materials. This clause explains that materials other than copper or aluminium may be used as earthing conductors if their resistance is no greater than that of a copper conductor of the required size and if their resistance to corrosion is suitable for the application. Clause 5.3.2.2 Conductor type. This clause explains that protective earthing conductors may be installed as separate conductors, installed together with live conductors in the same enclosure, incorporated within multi-core cables, or provided in the form of busbars. It also explains that, subject to special conditions, certain conductive parts such as wiring enclosures, cable sheaths, armors, screens, conductive frameworks, and catenary wires may be used as protective earthing conductors. It clearly explains that pipes carrying gas, water, flammable liquids, or similar non-electrical services must not be used as earthing conductors, although bonding to them may still be required. Clause 5.3.2.3 Special Conditions. This clause explains that when conductive wiring enclosures, cable sheaths, armors, screens, frameworks, or similar parts are used as protective earthing conductors, extra conditions apply. The electrical equipment must be supplied by live conductors contained within the enclosure, and there must be reliable electrical continuity between the enclosure and the equipment being earthed. Where cable sheaths or screens are used, the live conductors must be incorporated within the same cable. The clause also explains that certain exceptions apply for specific cable types where protective earthing conductors are associated only with the circuit supplied by that cable. Clause 5.3.2.4 Insulation. This clause explains that earthing conductors are generally required to be insulated. It then explains that some forms of earthing conductors do not require insulation, including aerial conductors, flat-braided conductors, busbars, certain cable sheaths, conductive frameworks and wiring enclosures deemed to be earthing conductors, copper conductors buried directly in the ground and catenary wires. Clause 5.3.2.5 Identification. This clause explains that insulated earthing conductors must be identified in accordance with the identification rules of the standard so they can be clearly recognized. Clause 5.3.3 Earthing conductor size cross-sectional area. This clause introduces the requirements that control how large earthing conductors must be, so they can safely carry fault currents and remain reliable over time. Clause 5.3.3.1 Protective earthing conductors. This clause explains that the size of a protective earthing conductor must be sufficient to carry prospective fault current for the time needed for the protective device to operate, must provide an appropriate earth fault loop impedance, must have enough mechanical strength and resistance to external influences, and must allow for any deterioration that may reasonably occur over time. Clause 5.3.3.1.1 General. This clause explains that the required cross-sectional area of a copper protective earthing conductor may be selected either from the appropriate table based on the size of the largest active conductor supplying the installation, or by calculation. It also explains several exceptions and notes, including how to deal with parallel active conductors, how to select sizes when conductor sizes do not exactly match the table, and how conductive enclosures or frameworks used as earthing conductors must have an impedance no greater than that of an equivalent copper earthing conductor. Clause 5.3.3.1.3 Calculation. This clause explains how to calculate the minimum size of a protective earthing conductor using a formula. In spoken form, the formula says that S equals I times the square root of T divided by K. S is the required cross-sectional area of the protective earthing conductor, measured in square millimeters. I is the value of the fault current, measured in amperes, that would flow through the overcurrent protective device if a short circuit occurred with negligible impedance. T is the disconnection time of the protective device, measured in seconds, that corresponds to that fault current. K is a factor that depends on the material of the earthing conductor, the insulation, and the initial and final temperatures the conductor can safely withstand. This clause explains that the calculated size must not be less than the result of this equation, and that if the calculation produces a non-standard conductor size, the next largest standard size must be used. Clause 5.3.3.2 Main earthing conductor. This clause explains that the size of the main earthing conductor depends on how it is connected. Where it connects the main earthing terminal to an earth electrode, its size is determined in relation to the size of the largest active conductor of the consumer mains, using the relevant table. Minimum and maximum copper sizes are specified. The clause also explains conditions where the size may instead be determined by the largest outgoing submain or final subcircuit, or by the minimum size needed to carry maximum demand. Where the conductor connects an earth bar to an earth bar within a supply substation, the size may be selected from the table or by calculation. It also explains that in these cases the main earthing conductor forms part of the earth fault current path and must be sized based on the prospective fault current and disconnection time. Clause 5.3.3.3 Aerial earthing conductors. This clause explains that aerial protective earthing conductors must be sized in accordance with the general earthing conductor rules and must also comply with additional requirements that take into account conductor type and span length. Clause 5.3.3.4 Earthing conductors and cables, flexible cables or flexible cords. This clause explains how to select the minimum size of protective earthing conductors when they are incorporated into cables or flexible cords. It explains the minimum sizes for single-core cables, multi-core cables, and flexible cords, including special conditions where smaller sizes may be permitted. It also explains the requirements for screen and drain wires and the exception where separation from live conductors by double insulation applies. Clause 5.3.4 Main earthing terminal connection or bar. This clause explains that every electrical installation must have a main earthing terminal, connection, or bar located at the main switchboard. All earthing and bonding conductors are required to be connected, either directly or indirectly, to this point so that an equipotential bonding network is formed. This includes protective earthing conductors, the main earthing conductor, the MEN connection, equipotential bonding conductors, and functional earthing conductors where these are required. It also explains that the main earthing terminal or connection may be a soldered connection. Clause 5.3.5 MEN connection. This clause introduces the requirements for the MEN connection, also known as the MEN link. Clause 5.3.5.1 General. This clause explains that every electrical installation must have an MEN connection at the main switchboard. The purpose of this connection is to link the earthing system of the installation to the supply neutral conductor by connecting the main earthing terminal or bar to the neutral bar. It explains that in some cases the neutral to earth connection may be made at other permitted locations, such as within an owner or user-operated supply substation, at a distributor's neutral bar, or through an earthing conductor or terminal provided by the electricity distributor. It also explains that the MEN or NE connection must be located in a position that is accessible for disconnection and testing. Clause 5.3.5.2 Size. This clause explains that the MEN connection must be a conductor that complies with the general earthing conductor requirements and must be large enough to carry the maximum current that could flow under short-circuit conditions. It explains that the minimum size must not be less than the current carrying capacity of the main neutral conductor, and for certain large switchboards it must be sized in the same way as a protective earthing conductor. It also explains situations where the minimum size of the MEN connection does not need to be larger than the main earthing conductor, such as where short-circuit protection is provided on the supply side of the consumer mains, or where double insulation of the consumer mains is maintained up to the supply protective device. Clause 5.3.5.3 Identification. This clause explains that where the MEN connection is insulated, the insulation must be colored green, or green and yellow, in accordance with the conductor identification rules. Clause 5.3.6 Earth electrodes. This clause introduces the requirements for connecting the earthing system of an installation to the general mass of Earth. Clause 5.3.6.1 General. This clause explains that the connection of the installation earthing system to the general mass of Earth must be made using an earth electrode. It also explains that while no specific resistance to earth value is required for installations connected to an MEN system, the combined earthing system must still meet the earth fault loop impedance requirements. It also notes that guidance on measurement methods is available in other standards. Clause 5.3.6.2 Types. This clause explains that earth electrodes must be selected so they can resist corrosion and have adequate mechanical strength, taking into account soil type and environmental conditions. It explains that electrodes must be of approved types, and that in some cases conductive reinforcement in concrete foundations that are in contact with the ground may be used instead of a separate electrode. Clause 5.3.6.3 Installation. This clause explains how earth electrodes must be installed. For New Zealand installations, vertical electrodes must be driven to a minimum depth of 1.8 meters. Where strip-type electrodes are installed horizontally, they must be buried with at least half a meter of cover and must have a minimum horizontal length of 7.5 meters. Clause 5.3.6.4 Location. This clause explains that earth electrodes must be installed in a location that maintains effective contact with soil that does not dry out excessively, such as ground exposed to weather or areas that naturally remain moist. It explains that electrodes must be separated from other buried conductive surfaces to reduce corrosion caused by electrolytic action, and that the connection between the main earthing conductor and the electrode must be accessible. It also explains that the location of the earth electrode must be identified at the main switchboard. Clause 5.3.7 Functional earthing conductors. This clause explains that functional earthing conductors provided only to ensure correct operation of equipment do not need to meet the same requirements as main or protective earthing conductors. It also explains that where earthing is used for both protective and functional purposes, the protective earthing requirements take priority. The clause notes that functional earth connections should normally be independent of protective earth and limited to the main earth connection point, and that where a clean earth is specified, the equipment manufacturer should be consulted. Clause 5.4 Earthing of equipment. This clause introduces the requirements for earthing different types of electrical equipment and conductive parts. Clause 5.4.1 General. This clause explains the general principles for earthing equipment. Clause 5.4.1.1 Exposed conductive parts. This clause explains that exposed conductive parts of electrical equipment must be earthed when the equipment is installed or could operate in an earthed situation, or where exposed conductive parts are electrically continuous with extraneous conductive parts located in an earthed situation. It explains that equipment protected by electrical separation does not require earthing, and that equipment supplied by SELV or PELV does not need to be earthed. It also explains that equipment with double insulation does not require earthing, provided the wiring and internal construction maintain that insulation under all conditions. Clause 5.4.1.2 Conductive building materials. This clause explains that conductive building materials must be earthed in accordance with the bonding requirements of the standard. Clause 5.4.1.3 Connection of electrical equipment to earth. This clause explains that equipment required to be earthed must be arranged so it can be connected to earth by protective earthing conductors or by other permitted earthing media such as conductive parts of cables, wiring enclosures, or switchboard frameworks, provided these comply with the earthing conductor requirements. Clause 5.4.2 Socket outlets. This clause explains that the earthing contact of every socket outlet must be earthed. It also explains that socket outlets supplied as separated circuits must be bonded to the protective bonding system, and that socket outlets supplied as extra low voltage circuits must not have an earthing contact. Clause 5.4.3 Lighting points. This clause explains that a protective earthing conductor must be provided at every lighting point, including where transformers supply extra low voltage lighting. It also explains situations where a protective earthing conductor is not required, such as certain pool and fountain zones, specific insulated lamp holders, lighting points earthed through conductive conduit or pipe, luminaires installed on non-conductive poles in unearthed situations, and extra low voltage lighting points. Clause 5.4.4 Luminaires. This clause explains that exposed conductive parts of luminaires must be earthed, except where earthing is not required under the general rules or where a protective earthing conductor is not required at the lighting point. Clause 5.4.5 Conductive supports for aerial conductors. This clause explains that conductive poles, posts, brackets, stay wires, and similar supports for low-voltage aerial conductors must be earthed. It then explains several exceptions where earthing is not required, such as where supports are permanently separated from conductors by double insulation, where adequate clearances are maintained, or where stay wires are effectively insulated within reach. Clause 5.4.6 Structural metalwork including conductive building materials. This clause introduces the requirements for earthing structural metalwork. Clause 5.4.6.1 General. This clause explains that structural metalwork forming part of a structure containing an electrical installation must be earthed where it is permanently connected to installation wiring. It explains that the size of the earthing conductor must be selected based on the size of the largest active conductor within the framework, and that for combined outbuildings each building must have its own earthing connection. Clause 5.4.6.2 Connection to protective earthing conductors. This clause explains that earthing of parts of structural metalwork may be achieved by connecting a suitably sized protective earthing conductor at one point, provided the resistance between the earth bar and all parts to be earthed does not exceed 0.5 ohms. Clause 5.4.7 Submersible pumps. This clause explains that exposed conductive parts of submersible pumps must be earthed by a protective earthing conductor terminated at the pump motor. It explains that the termination must be sealed against moisture and protected from mechanical damage and corrosion, and that this may be achieved by terminating at a housing terminal or an internal or external constructional component that meets the bonding requirements. Clause 5.4.8 Variable frequency devices. This clause explains that devices producing high-frequency currents in the protective earth can create dangerous touch voltages. It explains that these voltages may not be detected using normal test instruments, and that the manufacturer's instructions must be followed when installing this type of equipment. It also draws attention to the safety requirements for electronic equipment in AS 62103. Clause 5.5 Earthing arrangements. This clause introduces how earthing conductors are arranged within an installation so that all required parts are correctly connected, continuous, and able to perform their protective function. Clause 5.5.1 Main earthing conductor. This clause introduces the requirements for the main earthing conductor that connects the installation earthing system to the earth electrode. Clause 5.5.1.1 Arrangement. This clause explains that the main earthing conductor must run from the main earthing terminal, connection, or bar at the main switchboard directly to an earth electrode that meets the requirements of Clause 5.3.6. The conductor must be run as directly as practicable and must not be connected to the terminal of any accessory, luminaire or appliance. It also explains that, in some cases, the main earthing conductor may instead be taken to an earth bar within a customer's substation, or to an earthing conductor or terminal provided by the electricity distributor, including a distributor-neutral bar where required. It is noted that distributor-provided earthing arrangements may include a special earthing conductor, the conductive sheath of a supply cable, or a neutral bar at a substation. Clause 5.5.1.2 Connection to earth electrode. This clause explains that the connection between the main earthing conductor and the earth electrode must be accessible so it can be visually inspected and tested. It explains that access may be provided by an underground pit with a cover that remains accessible above ground, provided there is enough space for testing connections and the pit is clearly identified. Where reinforcing steel is used as the earth electrode, this requirement is satisfied by providing a test point on the main earthing conductor. The clause also explains that the connection must be made using a suitable device that provides good electrical conductivity, must be protected against mechanical damage at the location, and must be suitably protected against corrosion. Clause 5.5.1.3 Labeling. This clause explains that the main earthing conductor must have a permanent label at the point where it connects to the earth electrode. The label must clearly warn that the main electrical earthing conductor must not be disconnected. It also explains that where the method of connection does not allow disconnection, this labeling requirement does not apply. Clause 5.5.1.4 Resistance. This clause explains that the resistance of the main earthing conductor, measured between the main earthing terminal or bar and the earth electrode, including the electrode connection, must not exceed 0.5 ohms. Clause 5.5.2, Protective Earthing Conductors. This clause introduces how protective earthing conductors are arranged and connected throughout the installation. Clause 5.5.2.1, Arrangement. This clause explains that all protective earthing conductors must be directly connected to the main earthing conductor or to another point on the earthing system that is connected to the main earthing conductor. It explains that protective earthing conductors must not normally carry load current. The clause then explains that connections may be made at the main earthing terminal or bar at the main switchboard, at any point along the main earthing conductor, at a dedicated earthing terminal or bar at a distribution board that complies with the requirements, or at a suitable point on another protective earthing conductor arranged in accordance with the rules. Clause 5.5.2.2, Restricted Connections. This clause introduces restrictions on how protective earthing conductors may be shared or extended. Clause 5.5.2.2.1, Circuits. This clause explains that where a protective earthing conductor is incorporated in the same cable sheath or wiring enclosure as its associated live conductors, it must only be used to earth equipment supplied from that same circuit. It also explains that this does not prevent the use of an unenclosed common protective earthing conductor serving multiple circuits. Clause 5.5.2.2.2, Earthing of Equipment. This clause explains that a protective earthing conductor that originates at a distribution board must not be used to earth equipment that is supplied from another switchboard. Clause 5.5.2.2.3, Earthing Facilities for Distribution Boards. This clause explains that a protective earthing conductor originating at a distribution board must not be used to provide earthing facilities for another distribution board. It then explains exceptions where the earthing facilities originate from the same distribution board as the associated active conductors, or where a common protective earthing conductor connected to the main earthing conductor is used, provided continuity does not depend on terminals at distribution boards and there is a direct connection between the common conductor and any branch protective earthing conductors. Clause 5.5.3, Particular Methods of Earthing. This clause introduces specific earthing methods for certain installation situations. Clause 5.5.3.1, Outbuildings. This clause explains that all parts of an electrical installation in or on an outbuilding that are required to be earthed must be earthed using one of the permitted methods. It explains that an individual outbuilding may be earthed either by connection to a protective earthing conductor from the main installation, or as a separate MEN installation. It also explains that combined outbuildings must be connected to a protective earthing conductor and must not be earthed as separate MEN installations. For separate MEN installations, the clause explains that the submain neutral supplying the outbuilding becomes a combined protective earthing and neutral conductor, spoken as APEN conductor, and the outbuilding installation is treated as a separate electrical installation. It explains limits on the number of MEN connections, how distribution boards are treated, how the earthing conductor to the earth electrode is regarded, how submains may be run, and that the combined PEN conductor must not rely on parallel paths through pipes or structural metal. Clause 5.5.3.2, Wiring Systems. This clause explains that exposed conductive parts of wiring enclosures must be earthed at the end adjacent to the switchboard or accessory where the wiring system originates. It also explains that conductive sheaths, armors, and screens of cables or cords must be earthed at the same originating end. Clause 5.5.3.3, Electrical equipment supplied by flexible cord or flexible cable. This clause explains that exposed conductive parts of electrical equipment supplied by a flexible cord or flexible cable must be earthed by connection to a protective earthing conductor that is incorporated with the associated live conductors in the same sheath, braid, or enclosure. Clause 5.5.3.4, Switchboards. This clause explains that electrical equipment mounted on a conductive switchboard framework may be earthed by that framework, provided the framework complies with the protective earthing conductor requirements. Clause 5.5.3.5, Unprotected consumer mains. This clause explains that exposed conductive parts associated with consumer mains that do not have short-circuit protection on the supply side must be earthed by a conductor with a current carrying capacity at least equal to that of the main neutral conductor, or by direct connection to an earth bar of equivalent capacity. It explains that these consumer mains are those not protected by a service protective device, and that fault conditions may cause the earthing conductor to carry maximum fault current continuously for the duration of the fault. It also explains permitted connection points and notes situations where the requirement does not apply when double insulation is maintained and supply-side protection is provided. Clause 5.5.3.6 Conductive switchboard enclosures associated with unprotected consumer mains. This clause explains the earthing arrangements for conductive switchboard enclosures where unprotected consumer mains are present, including how connections are made to the main neutral conductor, the main earthing bar, and the ME link, depending on the insulation and protection conditions of the consumer mains. Clause 5.5.3.7 Additional notes and exceptions. This clause explains that systems using double insulation for aerial conductors may be considered as providing double insulation, lists examples of exposed conductive parts associated with consumer mains, and notes that upstream distributor protection may provide short-circuit protection in some cases. Clause 5.5.4 Continuity. This clause explains that earthing conductors must be protected so their electrical continuity is maintained over time. They must be protected against mechanical damage, chemical deterioration, and forces such as vibration or movement. Where painted or coated metal parts are bolted or clamped together, suitable devices such as star washers or similar methods must be used so paint or coatings are effectively cut through and a reliable earth connection is maintained across those joints. Clause 5.5.4.1 General. This clause explains that earthing conductors must be installed and protected in a way that ensures they remain electrically continuous and reliable throughout the life of the installation. Clause 5.5.4.2 Conductive wiring enclosures. This clause explains that conductive wiring enclosures and associated fittings that are required to be earthed, including those used as an earthing medium, must be mechanically secure and electrically continuous. It also explains that the impedance of the wiring enclosure earthing arrangement must meet the earth fault loop impedance requirements of the standard. Clause 5.5.4.3 Conductive sheaths, armors and screens of cables. This clause explains that conductive cable sheaths, armors, and screens that are required to be earthed must be mechanically and electrically continuous. Their impedance must be no greater than that required for an equivalent copper earthing conductor, ensuring fault currents can flow effectively. Clause 5.5.4.4 Connecting devices. This clause explains that where electrical equipment is connected by a plug-in socket or similar device, any earthing connection to exposed conductive parts must be made automatically before the live connections are made when the plug is inserted, and must be broken automatically after the live connections are broken when the plug is withdrawn. Clause 5.5.5 Installation. This clause introduces the installation requirements that ensure earthing conductors remain protected and effective. Clause 5.5.5.1 General. This clause explains that all earthing conductors and other earthing media must be installed to provide adequate protection against expected mechanical damage, accidental interference, and chemical deterioration. It also notes that in areas of high lightning activity, additional guidance should be considered. Clause 5.5.5.2 Protection against mechanical damage. This clause explains that earthing conductors must be protected against being displaced, damaged, or cut. Protection may be achieved by fixing the conductor with suitable clips or clamps that do not damage the conductor strands, by guarding the conductor with metallic barriers or other robust material, or by installing the conductor within a wiring enclosure. Clause 5.5.5.3 Protection against corrosion. This clause explains that earthing conductors and their fixings must be protected against corrosion, including corrosion caused by moisture or contact between dissimilar metals. In underground or damp locations, all joints and terminations must be sealed to prevent moisture ingress and fittings must be corrosion resistant. Where exposed to the weather, Joints and terminations must also be corrosion resistant and protected to prevent moisture entering and affecting the conductor. Clause 5.5.5.4 Aerial earthing conductors. This clause explains that aerial earthing conductors must be properly supported and must be identified in accordance with the conductor identification rules. Clause 5.5.5.5 Buried earthing conductors. This clause explains that earthing conductors buried in the ground or installed in underground enclosures must meet depth and mechanical protection requirements appropriate to the installation method. It also explains that bare earthing conductors may only be buried directly in the ground if they are copper and not less than 25 square millimeters. A conductor passing through a wall or partition is not considered to be a buried earthing conductor. Clause 5.5.6 Connections. This clause introduces requirements for how earthing connections must be made. Clause 5.5.6.1 Conductors. This clause explains that connections in earthing conductors must comply with the general connection requirements of the standard. Clause 5.5.6.2 Constructional components. This clause explains that exposed conductive parts of electrical equipment may be earthed by connecting a protective earthing conductor to a constructional bolt, stud, or screw that forms an integral part of the equipment, provided specific conditions are met. The terminal must be mechanically and electrically continuous with the exposed conductive part. The protective earthing conductor must be removable without reducing the effectiveness of the fixing or causing parts of the equipment to lose rigidity. Removing covers to access terminals must not disturb the earthing connection, and the bolt, stud, or screw must not be used to position or adjust the equipment. Clause 5.6 Equipotential bonding. This clause introduces equipotential bonding and explains that its purpose is to reduce the risk of dangerous voltage differences between exposed conductive parts of electrical equipment and extraneous conductive parts. Clause 5.6.1 General. This clause explains that voltage differences can arise from several sources, including faults on extraneous conductive parts such as water or gas pipes, load currents flowing through the soil, telecommunication system voltages on nearby equipment, and lightning discharges affecting the installation or incoming services. Clause 5.6.2 Arrangement. This clause explains that equipotential bonding must be provided in accordance with the detailed requirements of the following clauses so that potential differences are minimized between electrical equipment connected to the earthing system and other conductive parts that may independently contact earth. It also explains that additional equipotential bonding requirements apply in special locations and installations, including hospitals, explosive atmospheres, telecommunications installations, film and broadcast sites, photovoltaic systems, grid-connected inverters, generating systems, and separated circuits. Clause 5.6.2.2 Conductive water piping. This clause explains that conductive water piping that is installed and accessible within a building, and that is continuously conductive from inside the building to a point of contact with the ground, must be bonded to the earthing system. The bonding must be made using an equipotential bonding conductor connected to the main earthing conductor or earthing bar, as close as practicable to where the pipe enters the building. It also explains that this bonding must be to the earthing system of the installation and not directly to the earth electrode alone. Clause 5.6.2.3 Other conductive piping systems. This clause explains that conductive piping systems such as fire sprinkler pipes, gas pipes, water pipes, or pipes carrying flammable liquids that are unavoidably in contact with exposed conductive parts of electrical equipment must be connected to that equipment by equipotential bonding. It also explains that bonding is not required where the piping system is already effectively earthed through its connection to associated electrical equipment. Clause 5.6.2.4 Conductive cable sheaths and conductive wiring enclosures. This clause explains that conductive cable sheaths, armors, or wiring enclosures associated with circuits operating above extra low voltage must either be bonded to conductive pipes containing flammable agents to prevent dangerous voltage differences, or be separated from those pipes by specified clearances or insulating barriers where bonding is not practicable. Clause 5.6.2.5 Showers and bathrooms. This clause explains that any conductive reinforcing material within concrete floors or walls of rooms containing showers or baths must be bonded to the earthing system. It explains how equipotential bonding conductors are to be connected and provides guidance for combined outbuildings, continuous reinforcement, and existing installations, with the aim of avoiding potential differences in these locations. Clause 5.6.2.6 Swimming and spa pools. This clause introduces the special equipotential bonding requirements for pools and spas. Clause 5.6.2.6.1 Bonding arrangement. This clause explains that an equipotential bonding conductor must be connected between the conductive pool structure, specified items of electrical equipment, conductive fixtures and fittings, and the earthing conductors of circuits supplying the pool or spa. It also explains that the resistance of this bonding conductor between these items must not exceed 0.5 ohms. Clause 5.6.2.6.2 Conductive pool structures. This clause explains that where the pool structure is conductive, extraneous conductive parts including reinforcing metal must be bonded to a pool equipotential bonding connection point, which is also bonded to the earthing conductors of the circuit supplying the pool or spa. It explains situations where additional bonding is not required when electrical continuity is already ensured. Clause 5.6.2.6.3 Pool equipotential bonding conductor connection point. This clause explains that a dedicated bonding connection point may be used for pool bonding. It must be accessible after construction, clearly identified, correctly designed, protected against mechanical damage, and protected against corrosion. Clause 5.6.2.6.4 Electrical equipment. This clause explains that exposed conductive parts of electrical equipment in pool zones, and equipment in contact with pool water, must be equipotentially bonded. It also notes situations where separation or insulation means bonding is not required. Clause 5.6.2.6.5 Conductive fixtures and fittings. This clause explains that fixed conductive items within arm's reach of the pool edge, such as ladders, diving boards, fences, pipework, and reinforcing metal, must be included in the equipotential bonding system where required to prevent dangerous voltage differences. Clause 5.6.2.7 Telephone and telecommunication earthing systems. This clause explains that telephone and telecommunication earthing systems may be connected in common with the electrical installation earthing system. The purpose of doing this is to reduce the risk of dangerous voltage differences appearing between the two systems during faults or abnormal conditions. If the telephone or telecommunication earthing system is directly connected to the electrical installation earthing system, it must be connected either to the electrical installation earthing system at a dedicated enclosed terminal provided for this purpose, or directly to the earth electrode using an independent connecting device that is clearly identified. Where an enclosed terminal is used, several conditions apply. The terminal must be connected to the main earthing conductor of the electrical installation via protective earthing conductor in accordance with Clause 5.5.2. The terminal must not be installed inside a switchboard. It must be installed in a convenient and readily accessible position, and the minimum cross-sectional area of the protective earthing conductor used for this connection must be 6 square millimeters. This clause also notes that in Australia, installation requirements are covered by ASNZS 5009, while in New Zealand, guidance is given in the TCF Premises Wiring Code of Practice. Further detail on bonding arrangements is provided in Appendix F. Clause 5.6.3 Bonding conductors. This clause introduces the requirements for equipotential bonding conductors. Clause 5.6.3.1 General. This clause explains that the selection and installation of equipotential bonding conductors must follow the same general principles as protective earthing conductors in Clause 5.5. The key focus is ensuring safety by maintaining effective electrical bonding. An exception is noted that the size of an equipotential bonding conductor is determined in accordance with Clause 5.6.3.2. Clause 5.6.3.2 Size. This clause explains that the size of equipotential bonding conductors must be selected based on the specific bonding application and the detailed requirements set out in this clause. For conductive piping, cable sheaths and wiring enclosures, the equipotential bonding conductor required under clauses 5.6.2.2 to 5.6.2.4 must have a cross-sectional area of not less than 4 square millimeters. For showers, bathrooms, swimming pools and spa pools, the equipotential bonding conductors required under clauses 5.6.2.5 and 5.6.2.6 must also have a cross-sectional area of not less than 4 square millimeters. For telephone and telecommunication earthing systems connected in accordance with clause 5.6.2.7, the equipotential bonding conductor must have a cross-sectional area of not less than 6 square millimeters. This clause also explains that in some swimming or spa pool situations, the size of the equipotential bonding conductor may be determined as for an earthing conductor, where the bonding conductor is incorporated within a multi-core flexible cord supplying equipment that must be removed for maintenance. Clause 5.7, Earth fault loop impedance. This clause introduces earth fault loop impedance as a key factor in ensuring automatic disconnection of supply. Clause 5.7.1, General. This clause explains that effective fault protection by automatic disconnection of supply works by disconnecting the supply to the faulty part of the installation in a way that limits touch voltage to safe values during an insulation fault. Automatic disconnection depends on both the characteristics of the circuit protective device and the impedance of the earthing system. If the touch potential exceeds 50 volts AC or 120 volts ripple-free DC, the protective device must disconnect the supply within the required time. Clause 5.7.4, Impedance. This clause explains the condition that must be met to ensure automatic disconnection of supply. The requirement is expressed by the relationship ZS times IA is less than or equal to UO. Now let's explain what this means in simple spoken terms. ZS is the impedance of the earth fault loop. This includes the impedance of the source, the active conductor from the source to the point of fault, and the return path from the point of fault back to the source through the protective earthing conductor and the neutral. IA is the current needed to cause the automatic operation of the protective device within the required disconnection time. In other words, it is the fault current that will make the fuse blow or the circuit breaker trip fast enough. UO is the nominal AC voltage to earth, which in a standard New Zealand installation is 230 volts. What this formula is telling us is simple. The total impedance of the fault loop must be low enough so that, when a fault occurs, enough current flows to operate the protective device quickly. If the impedance is too high, the fault current will be too small, the device will not trip in time, and dangerous touch voltages may remain on exposed conductive parts. So, to comply with this clause, the measured or calculated earth fault loop impedance must always be low enough to satisfy this relationship. The notes explain that additional requirements apply in patient areas of hospitals and similar locations, that the return path includes both protective earthing and neutral conductors, and that Appendix B provides guidance on calculation methods and measurement techniques. Clause 5.8, Other earthing arrangements. This clause explains that where fault protection is provided by electrical separation, protective earthing conductors and equipotential bonding conductors must be arranged in accordance with Clause 7.4. It also explains that some earthing systems should be independent systems. However, if they are connected to the electrical installation earthing system, they must not reduce the integrity of the electrical installation protective earthing system. Examples of these independent systems include lightning protection systems, static electricity protection systems, radio frequency interference screened installations, information technology installations, explosion protection systems, and cathodic protection systems. The clause finishes by noting that requirements for protective earthing and bonding for these systems may be found in other standards. That brings us to the end of Section 5, Earthing Arrangements and Earthing Conductors. In this section, we've covered how earthing systems are constructed, how bonding reduces dangerous voltage differences, and how earth fault loop impedance ensures fast and safe disconnection of supply. These requirements form the foundation of electrical safety in New Zealand installations and are essential knowledge for everyday electrical work and for EWRB examinations. Always remember, correct earthing saves lives and protects property. In the next section, we'll move on to the next set of requirements in the standard.